Differentiate the function with respect to x. In other words, find dy over dx if y is equal to square root of e raised to the power of arc-𝐶 over x plus 1 raised to the power of sin x apata 𝐴.
To solve this type of ambiguous question, let us get started by simplifying the equation. But before this, I will like to outline some tips and techniques of simplifying this.
The first is to take the natural logarithm of both sides. This rare idea helps to simplify the exponents associated with the question. Without this idea, one will have to use chain rules stressfully. The second idea, which follows the first, is to differentiate each step implicitly, given that we have a multivariable function on both sides of the equation. Derivative of each terms come easy after the first breakdown with natural logarithm. The third idea is to make dy over dx the subject of formula. Do not forget that this is our aim from the beginning. After this, you may convert your result to a function in terms of x. Let's get started. Start by writing out the function. To break down the tower on the right-hand side, let us take the natural logarithm of both sides. This will simplify the load on the left-hand side, which will make the differentiation come easy. No matter the level of the exponent, always introduce the natural logarithm to simplify it. This is a technique that you should never forget. Just like the logarithm, the natural logarithm also possess a lot of properties. The properties of logarithm and natural logarithm are same. Therefore, we should encounter problem in separating the natural logarithm of numerator and denominator. For instance, ln a over b is equal to ln a minus ln b. Also, ln a raised to the power of b is equal to b ln a. Ln e is equal to 1, we can cancel it off. This is just like taking a function and its inverse. Now, we are left with the power of e. Don't also forget that e is the exponential function of 1. So, the terrifying function is what we have simplified to this level. Now that we have simplified the question to what we can easily differentiate, it is now safe to differentiate each terms. We have our function here on a new page. Ln y equals 1 over 2 cut inverse of x minus in x ln x plus 1. Now, let's differentiate each. Let us start with the derivative of ln y. The derivative of ln y is equal to 1 over y, then attach dy over dx because we just derivated with respect to y. To differentiate cut inverse of x with respect to x, let u equals cut inverse of x. Our aim now is to find du over dx. By taking cut of both sides, cut u equals x. Cut u can be separated into cosh u over sin u. And here, the idea of quotient rule comes in. If the numerator of a function of u and the denominator is a function of v, derivative becomes v du over dx minus u dv over dx over v square. This is the same idea we want to apply here. Then by quotient rule, with z that the left-hand side is equal to sin square u minus cosh square u over sin square u du over dx. And the right-hand side gives 1. Just as the trigonometric functions have identities, the hyperbolic functions also have identities, which is similar, but not same. Cosh square u minus in square u equals 1. This satisfies the numerator on the left-hand side, and it gives minus 1. The second formula also has its role to play at another stage in this progress. The second identity helps to convert our result here to a function of cut square u, so that we can return our substitute. So, we replace cut u with x. Then we conventionally make dy over dx the subject of formula. Then we have du over dx equal 1 over 1 minus x square. So, the derivative of cut inverse of x is equal to 1 over 1 minus x square. For the third function in the sum, We notice that it is the product of two functions. So, we gonna apply the product rule. Let u equals sin x ln x plus 1. du over dx is given as sin x multiplied by the derivative of ln x plus 1 plus ln x plus 1 multiplied by the derivative of sin x. Without prolongation, du over dx is equal to sin x over x plus 1 plus ln x plus 1 cos x. So, the derivative of sin x ln x plus 1 is equal to sin x over x plus 1 plus ln x plus 1 cos x. Now let's collect our results together. We have the following. And by multiplying both side by y, we make di dx the subjective relation. Modification, by leaving a result in term of x, we can substitute the value of y into the expression on the right-hand side. We have the following. dy over dx equals 1 over 2 times 1 over 1 minus x square, minus in x over x, plus 1, minus cos x ln x plus 1, multiplied by square root of e to the power of 𝐾𝐃, inverse of x, over x plus 1, raised to the power of sin x. Finally, we arrived at a valid conclusion.
Till finish and win the war. I'm gonna keep on receiving from the one I